This is the last additional exercises that we'll be doing in Math 1103, and it's section 6 of chapter 5. And here we're going to be doing division. And as we've mentioned, as we go along, what we're looking for is strategies. So in dividing, we have a trinomial on top that's divided by a monomial. In fact, we see it in example 2, example 3, 4, and 5. So what I'll do is I will set these up and then show you the technique for solving them. So the technique is, if we have a trinomial, we're going to divide it into the 3 terms on top and then take this common denominator and put it under each term. Now that we have distinct terms, we're going to simplify each term. So 6 goes into there 6 times, and you get 6x squared. 6 will go into there 4 times, and don't forget the negative sign. And here 3 times, and the negative sign. Now here a goes into a to the third, a to the second. The b's just cancel out. Don't forget the negative sign. A will go into there once, and b to the third. And here 5 will go into there twice. Watch the negative sign. And 6, take out one of the p's. And here we have 4, a to the second, minus 3a, and then plus 2. Now, these all came out, and they're rather easy. Again, divide them into individual terms, and then put your denominator under each one and just simplify. Now, one that they're not showing here that I'd like to do, I'm going to modify this one just to show you what can happen sometimes. Instead of 6 by itself, we're going to say 6a. Or let's put an X there. This is going to be 6x. Now, what would happen here? Well, again, we simplify. So this just becomes 6x. This is going to become a negative 4. Now, this is sort of interesting because the 6 will go into the 18 3 times, but we're left now with an x in the denominator. Okay? So in some divisions, you may expect something like this, where something is left in the denominator. It doesn't cancel out completely. So that's just a little thumbs up. In these next two, again, the same procedure. And, you don't have to put the physical line there, but it's okay if you do, because you're dividing a trinomial now up into 3 distinct terms with the common denominator under each one, and then you simplify. using the rules that we've gone over already. And the same thing here. Watching the signs and double checking your work. Now in number 8, we see something different. We have a trinomial that's divided by a binomial. So I'm going to take some time to show you this process. And by the way, there is a typo here. This should be a 2. So this we're going to set up as long division. So x minus 8 out there. Set up our division pattern. And put our trinomial under the typical division bar here. So there's our denominator that we're dividing into our numerator. Now, what's the technique here? Well, we're going to see how many times x will go into this. And a good technique is just put it here. Do like we did before. And this is going to be 5x. Because this cancels out and we get 5x. Now, our next step is to take the x and multiply it by the 5x. So it gives you this first term. Now we take this second item, negative 8, and multiply it by this, and we get a negative 40x. Now, what did we do in elementary school when we had division? Well, we put a line there, and what did we do with these? We subtracted them. Now, when we have signed numbers, that isn't always a good thing if we do it mentally. So in algebra, what we do is to subtract, we change the signs, and then add. So these will cancel out. That's what we're looking for. And now this ends up as a 3x, and then we bring this down. And then again, we say 3x divided by x is going to go 3 times. So the x's just cancel out here. So we now go x times 3 is 3x. Negative 8 times this is a negative 24. And what do we do now? We're going to subtract. And we do so by changing the signs and adding. And these all just cancel out. So if we were to multiply this through FOIL, didn't want to do that, we get this over here. I remember the first time I did this and I had the 3 in there, it didn't work out. And I'm saying, why did it give such a difficult example? That's why I knew that was a typo. Going on now to number 9. Again, we've set it up. And x goes into there. I think we can just say it's x. This times this always needs to give you that first term. This times this is a plus 7x. Put a line there, and through the magic of color change, I'm going to change my signs. So these cancel out. This will give me a 3x plus 21. Again, 3 goes into 3x, x 3 times. So x times 3 is 3x, which is what we're looking for. 7 times 3 is a positive 21. And again, we change our signs, and everything cancels out. So once again, this times this will give you this. So they're giving us some easy examples. X goes into there, again x. So x times x is x squared. 5 times x is a positive 5x. Change our signs. This cancels out. This adds up now to a negative 8x. Bring down our negative 40. Now, x goes into there, a negative 8 times. X times that is negative 8x. This times this is a negative 40. And change our signs. These all cancel out. So in number 11 now, it's a little different. Again, how many times does this go into that? And you do so by using that little technique if you're not sure. Divide it. And the answer is just x times when we simplify this. So now this times this gives us our first term. This times this gives us a positive 1x. So my wife was asking, what did I want for lunch? Isn't that a good deal? Okay, so we have done this. Now we're going to subtract by changing the signs. These cancel out, and here I get a negative 12x. I bring down my negative 3. Now 4x goes into there, a negative 3 times. And you could use that technique if needed. But usually you can do it mentally. Now 1 times this is a negative 3. Now notice so far we haven't had any remainders. But that's a possibility. And everything cancels out. Now, you may have mastered the skill, but we're just going through these, so you can advance it to something you may not know how to do and want a little help on. But again, it would be 12x squared divided by 3x. That's going to give us a 4x. Or you could do it mentally. So this is 12x squared. 2 times this is a negative 8x. Put our line. This is critical. You have to change the signs and then add. By changing the signs, you are subtracting. This becomes 3x minus 2. Well, 3x goes into there how many times? Well, once. So 3x minus 2, change the signs, everything cancels out. So this one's a little different in that it's longer. Now again, there is a protocol in doing these. We put them in the degree, the highest, in a descending order. Now if for some reason one of the powers were missing, you would put a placeholder when you're setting up these divisions, such as 0x squared. If there was no x squared example or term, you'd have to put that in. Now, it doesn't have any value, but it occupies a space, so we can do it sequentially. So let's just do this one. This is going to be 3a squared. This times this gives me 3a cubed. This times this gives me a positive 15a squared. And to save time, I'll work this one out. So as we continue with this, we've changed the signs, subtracted, ended up with a 5a squared A goes into there 5a times our next row. And again, change the signs. I end up with a negative 4. A goes into a negative 4a, negative 4 times, multiply through, and I change signs, and everything works out. As we go on to example 15, we see something different here. Notice this is x to the third. There is no x to the second or x to the first. So we have to do something different. Let me set it up. So here, in setting it up, as I mentioned before, if there is a power missing, we have to put a placeholder that has no value, but as we work through the system, we have a place to put it. So let's get started. X will go into here, x to the second times. So x times x to the second is x to the third. 5 times this is a positive 5x squared. Put our line, change our signs, and this becomes 5x squared, a negative. Bring down my 0x. Now x will go into there, negative 5x times. This becomes a negative 5x squared. This becomes a negative 25x. Change my signs. This becomes a positive 25x. And I bring down my 125. Now x goes into there 25 times. X times this is a positive 25x. This times this is a positive 125. And we change our signs, and there's no remainder. All right, so the key to this is that, interestingly, this is the sum of perfect cubes and actually factors into these two factors. Now, a little later, in actually the next section, they're going to do some factoring of this, where we factor the sum and then sometimes the difference of perfect squares. We'll be doing this one shortly. Don't have to change positions. So 3x goes into there, 9x squared times. So 3x times this gives me my first term. Now 4 times this is a negative 36x squared. Now what we're going to do is change the signs and add. So this gives me 36x squared. Bring down my 0x. And 3 goes into there. Plus 12x times. Now, 3x times this gives me 36x squared. A negative 4 times this gives me a negative 48x. We're going to change our signs and move on. So this becomes a 48x. and I bring down my negative 64. Now 3x goes into there 16 times. And this gives me 48x minus 64. Oh, it's working out very well. And we're going to change our signs. And everything comes out. And these are the factors of this, which is the difference of perfect cubes. Now, they didn't give you really many difficult ones here. I like this. This is they're giving you some drill in the basics. But as we look at number 18, this is a little different. So let's start to set it up. So it's going to be 3b minus 1 divided into now notice the way it's set up. They're not in descending powers. So you have to do that. So this is going to be 6b squared there. Then the negative 5b. And then our plus 4. So 3b goes into there 2b times. This times this is 6b squared. This times this is a negative 2b. I usually do my Shakespeare soliloquy at this time, but I passed up on that. To be or not to be? Okay, change our signs. This now becomes a negative 3b. I bring down my 4. And again, 3b goes into there a negative 1 times. This times a negative 1 is a negative 3b. This times this is a positive 1. Now, again, the key is change the signs. Notice when you do, you end up now finally with a remainder. How do we write that in MathLab? Well, since it's a plus, we just go plus 3 over our original denominator there, which is 3b minus 1. And that's how you do it. Now these others, again, they're giving you the area and the length. So you're going to divide the length into area. And this is, again, length into area to find the width. So we've done some like this, and we're already at 25 minutes. So I'll wrap this up, and good luck in the course.